We have a nozzle on top of the chamber. Now we have started to generate the mist. The nozzle is right here. Here is the nozzle. So this nozzle generates an ultrafine mist. Diameter is in the range of 10 microns. And this mist has some physical properties that are very special. It means that the size of these droplets makes the droplets hard, very hard. So they when they touch together, they bounce, and they don't stick, and they don't. So they are bouncing together, and also they are bouncing on the surface of the surface of the enclosure and the material. As you can see here, there is no condensation, no larger droplets. That you know, when you take a shower, you have a lot of condensation, a lot of water that goes down, and here there is no effect like this. So it means that this dry mist stays into the environment. And here you can see the aeration. So all this mist is taken out from the enclosure. So this is a static process, no mixing. Any question? Okay, let's move through the first one. Okay, some science behind, the rocket science behind this dry mist. So we have this nozzle that generates ultrafine droplets, about 10 microns. And the phenomenon, because of the small size of the droplets, the droplet bounce and do not burst upon collision. So they stay into the environment and they behave like a gas. While large droplets burst and make things wet. Like in the, so now you know that in your shower you have large droplets, not thin droplets. And here there are some examples of material lock. So you can have small size, big size, up to several meter cubes, and you can apply this process. And this is the diagram of the process. In this case we have the biocide tank that is right here. The generation of the small droplets is through the nozzle, so there is the liquid is through a Venturi effect is created by clean compressed air, and then after the dwell time conditioning, so aeration, fresh air, and it goes out. Okay. And this is the cycle for the chlorine dioxide. In this case, the conditioning of the enclosure, I need to increase the relative humidity, as I told you before, to wet the spore shell and to let them easy to be killed. Introduction of the gas, dwell-time aeration. As you can see, more or less all the cycles are the same. And this is the diagram for the chlorine dioxide. We start from a cylinder of nitrogen mixed with 2% of chlorine gas, 2-3% of chlorine gas. This gas is delivered to CD generating cartridges and then delivered to the enclosure. The quantity is controlled by an analyzer, spectrophotometer analyzer. On the conditioning phase, I add some vapor to make the humidification, and then at the end, aeration and CO2 catalytic converter that are charcoal filters. The chlorine dioxide is capable to penetrate load pattern like this, very stacked load pattern, while the other system you need to give some space in between to let the biocide penetrate much better into the load. So this is a comparison of different methods. UV, chlorine dioxide, hydrogen peroxide. Cycle time, I don't consider UV because it is not a reliable system. Why UV is not a reliable system? I put a question to you. UV light. Okay, now I can use this fantastic model.
Maybe I can add another lamp on the other side. But in any case, there will be for sure some parts with the shadowing effect. And what is in the shadow is not invested by the UV ray, and therefore the capability of log reduction of UV and system, it's a range of a couple of log reduction, not two log reduction. And they are not stable. Not stable because it's difficult to position everything in the same. Right? The root patterns is very big.
Did you hear the last one? Okay. So, going back. The comparison is between chlorine dioxide, hydrogen peroxide, and dry mist. point of dry mist peracetic acid is that you cannot monitor the concentration during the dwell time. But efficient-wise, it's efficient as the other one. The weak point of the chlorine dioxide is that you are dealing with chlorine, that is a little bit dangerous. And the hydrogen peroxide, the weak point is eventually the stratification of the hydrogen peroxide if you do not take measure to break the clouds. So if you get a complete turbulent environment, no issue with the hydrogen peroxide. Hydrogen peroxide is able to perform cycle time from on to the load downloading. It's about from 45 to 70 minutes. That is really good enough for all pharmaceutical processes. Okay, almost 10:30. I suggest to make a break now. And then we start after 15 minutes, I guess. Okay.